Hey, I'm Kevin O'Connor, a solutions engineer here at HashiCorp, and today I'm going to be providing an overview and demo of HashiCorp Vault Radar, our tool which provides an automated way to detect and manage secrets. So for starters, you might be thinking like, hey, doesn't Vault already manage our secrets? What's this all about? And, while that might be partially true, the aspect which has been missing up until now is the ability to really scan developer tools that are being used across your organization to ensure that secrets aren't leaked and therefore putting you in a compromising situation, right? Because more or less, as we all know, secrets are really the lifeblood of connectivity between our users and system to system as well. And leaking them into public areas is really a prime culprit for breach. So, Vault Radar, or HCP Vault Radar as it's known, really provides a secure and automated way to detect and manage secrets. And it can scan locations like GitHub, Confluence, Bitbucket, and others to really identify exposed secrets. And then once they're detected, those can be safely copied from Radar to a Vault cluster using our key value secrets engine, all without needing to manually transfer them, right? Which really enables developers to begin using Vault immediately without handling secrets directly and reducing the risk of accidental exposure. So let's take a bit of a step through our diagram here to go through what we'll be covering today with the demo. So as we can see, I've got Radar up there, known as HCP Vault Radar, like I mentioned, just for simplicity's sake, and to avoid any confusion with Vault Dedicated, I'm just going to be calling it Radar. So we have Radar, and as I mentioned, it can scan a number of different what we call data sources: Confluence, Bitbucket, GitLab, Jira, GitHub, as well too. And there's some custom scanning that you can do as well in addition to this. But for the purposes today, we're going to be scanning GitHub and a number of repositories within GitHub. We are then going to actually leak a secret. So I'm going to do, a commit or a pull request and put in like an API token in plain text that I'm looking to commit to a repo, kind of simulating a leak, like would happen in the real world. Radar is going to pick up on that through a scan and basically flag it and say, "Hey, we've got an actionable event here." And using an integration with Slack, it's going to automatically notify, the specific Slack channel that I've set up for that. In reality, that would be something, our DevOps team would be monitoring, basically saying like, "Hey, you have an API token that's in plain text." From there, I'm going to step through and actually sync that secret from Radar into Vault before then actually cleaning up the exposed secret in GitHub as well too. So deleting or closing the pull request and then deleting the associated branch with it to make sure that that plain text secret is no longer in GitHub. So at that point, at the end of the day, Radar will have picked up on the leaked secret. It will have synced it to Vault, and will have cleaned up the secret in the exposed area, right? So then from that point forward, really your applications and users would be able to pull the secret directly from Vault. So they can, use it for their day-to-day operations, and I'll show an example of what that looks like as well too. So that users are no longer even exposed to the secret, right? And your app, in this case, GitHub, maybe a GitHub Actions or something like that, would be able to pull the secret directly from Vault as part of its kind of pipeline, generation kickoff process, whatever it may be. Okay, so that is it from kind of a walkthrough standpoint. So let's get into Vault Radar, and I'm actually going to step back here for a second, just kind of show you guys, the HashiCorp Cloud Platform. If you haven't seen it before, this is it at a high level, right? We have a number of our different products along the left-hand side here, Boundary for user access, Console for kind of service-to-service access, Packer, Terraform, Vault Dedicated, right, which is what you may be familiar with if you're familiar with Vault. And then we have Vault Radar, which I'll be demoing today, right? Um, let's get to the overview page, right? As we can see here, this is kind of the top 10, what we call resource risks or highest risk resources that Radar would be showing. In this case, I only have seven. I think they're actually eight. Oh no, seven resources here that I have connected, right? And all of them are GitHub repositories. But a resource from this standpoint is essentially like a data source, right? So these again could be like I could hook this up to Confluence, Bitbucket, other Git repos, those sorts of things. But as we can see, some of them already show exposed secrets. So we can take a look at the first one here, this first repo that I have. And here we can see kind of detailed information about the selected resource, right? And at the top, we have three risk categories: secrets, PII, personally identifiable information, and non-inclusive language. And if we actually click into the risk itself, it'll step us down to this events page here. And in this view, we can really see, let me expand the first event here, right? We can really see the severity of each event, kind of a description of the event, essentially indicating the type of secret that's detected. We get a little bit of context on it, like where is the secret? And this is basically the path of our GitHub repo that we have. Um, the managed location, which is great because this would be telling us if this was a secret that was stored in Vault that then got leaked, right? Like, hey, it should actually be, or it was vaulted previously, but whoever accessed the secret then leaked it um, after the fact, right? And then we get a little bit more information, like maybe on the author, and then the status as well too. So currently this is unreviewed, but if I resolved it or if it was a false positive, I could mark it as such, and then it would clear the alert. Also, this will be telling us when we do sync it from Radar to Vault that we've done so there. Okay, so now, done a bit of a high level overview. Let's look at some configurations and settings that enable Radar to scan and remediate issues that we may find. So if we hop into settings down here, we are at the top line under data sources, right? And this is where Vault Radar scans for secrets, right? In this example, we have GitHub configured and we have 7 active monitored resources in this case, which are all kind of individual repositories that are configured within it. As I mentioned before, this is where we would also be showing things like Confluence, Bitbucket, and more if we had more from the list. But let's go ahead and try and add a new one to see the full list of available options. So we'll go and add a data source. And as we can see, before we can even view the full list of data sources, we're actually prompted to select a scan method. So Vault Radar offers 2 types of scanning. One is fully managed by the HashiCorp Cloud Platform, and another uses a self-hosted agent that runs inside your own environment. If you're familiar with agents and why they might be used, that's great. But just as kind of a quick refresher, right? The first option, you would really need inbound access into your environment from HCP in order for it to work, right? So the scanning would be done from HCP, and you need to open up, the firewall rules or whatever it may be in order to allow HCP to essentially access the environment to scan. The agent method allows the agent to kind of run within your own private network. This could be on-prem or in the cloud, and you therefore only need kind of outbound access from the agent to HCP. So you don't need to open up any firewall rules inbound, right? So it's great for either private networks in the cloud or on-prem resources as well too. For simplicity's sake, let's just select HCP Vault Radar Scan and we'll get the full list here of available data sources, right? Which again include both on-prem and cloud-based versions of supported platforms. For this demo, we're not going to add a new data source since we already have one configured. All right, stepping down, we'll go to the Secrets Manager section. And this defines the destination where Vault Radar will store detected secrets, right? So this step is necessary for kind of securely transferring secrets. Once Radar picks up on it, you then want to vault that secret somewhere, right? So this is that kind of address or end location where the thing is going to be vaulted. In this case, obviously, we're using HCP Vault. And we have a vault cluster configured beforehand. So if I actually click on this, we can see essentially how Vault Radar connects to our Vault cluster and scans for available namespaces, which are all indexed and stored by the Vault Radar agent for use as destinations for secrets, right? The other nice thing here is that this index can also be used by Radar to know if an unsecured secret it finds through a scan is also stored in Vault and has been mishandled and let out into the wild, right? Like that kind of example that I just spoke about a few minutes ago. Great. So let's explore the agent section a little bit now, just to touch on this. And here we can view essentially, the agent currently connected to Vault Radar, right? The first step in this would be to create an agent pool and then configure your agent to run and securely connect with HCP. Again, if you've used agents in the past, say for like a GitHub Actions runner or something like that, it's fairly similar. And we'll use the agent to initially scan and then monitor the data sources on an ongoing basis. The last thing I want to touch on in settings here is this remediation tab. And if we actually step over to actions as well too, right? In this kind of remediation space under the actions tab, you'll be able to see that I've configured the repository sources that I want to map to my Vault instance, and then essentially set the path and the secret mount that we want to copy secrets to, right? So basically, we have all of our radar resources here on the left. um, we have, these are essentially all the repositories that I have in GitHub, right? Then we have the secrets manager location, which is the same for all of these because we're using the same Vault instance, right? That's just our Vault address. But then we have individual mount paths or backend paths in Vault that map to each radar resource, right? Um, and so to basically accomplish this, you download what's called a mappings CSV, and then you add the path to your secret mount and secret path, and then just upload it. But we structured it this way that we can link kind of one KV mount in Vault per resource in Radar, right? And we've kind of named them as such, right? So we have repo one, and then we have repo one backend path, repo two backend path, to really allow us to better manage permissions and really enforce proper segmentation. Okay, so let's get into the fun stuff, right? Now that we have a solid understanding of what Vault Radar does and how its components work, I want to simulate a real event. And to do this, we'll use an existing GitHub resource that's already been scanned, but currently has no detected secrets. Right, so if we go back to our resources here, we can see that we have this repo down here that's been appended with kind of a random bunch of characters. This is a resource that we're going to be using, and it actually links out to, right, this target repo that we have within GitHub. And this is going to be our test repository for simulating a leak, right? We're going to introduce a new secret here and watch Vault Radar detect it in real time. And we're going to do that by adding a file to the repo that has, quote unquote, sensitive content in it, right? So let's go ahead and add a file. We'll create a new one. And we're just going to call this confluence.tf. And I've got some example code here that I'll just paste in for time's sake, right? But you can essentially think this is like Terraform code that's calling on the Confluence provider. And as part of that, it needs a token for accessing Confluence, right? So we have this token here that starts with ATT3X, right? Great. Okay. Well, I'm, very inexperienced developer here, and I'm about to try and commit a change to my repo that has a plain text API token in it. That's a big no-no. We'll create a new branch for this, and let's just give this a name called add uh, Confluence credentials. Sign off and propose changes. All right, this should go through no problem. Okay, let's make sure, right, we're comparing my change to main. Perfect. We'll create the pull request. And we've now added a sensitive credential to a file in GitHub, just like it could happen in a real environment. So of course, someone else would come in here and like review the change and merge the request. But before that, as I mentioned before, there are integrations for automatically notifying your teams and communicating to them when leaks happen. And HTTP Vault Radar does provide that integration to kind of route events that are generated, right, to either messaging or ticketing or incident management tools. For example, here, the Slack integration gives you real-time notification when someone tries to commit code with an exposed secret. So I'm going to show you how that works. Actually have a sandbox Slack account set up here. And in this Slack channel, you can see, right, it's 10:17 a.m. right now. Just a minute ago, when I created that pull request, the message notified me of, an unsecure um, secrets found in the file. So then I'm able to either investigate it or, assign to the appropriate owner to kind of triage the problem. There's a link that takes me directly to the location of the secret for kind of quick investigation. If we do view findings on the data source, right, this is going to take me right out to GitHub and highlight what it found, which again is that plain text token. Um, But at this point, we'll want to use Radar to kind of triage this and secure the secret, right? So also back within our Slack message, it also links me to the event directly within Radar, right? So this discovered some form of secret assignment in the resource. Best practice is to store the secret in Secret Manager and revoke the found secret. So that's what we're going to be doing. So I can open this up. This is going to take me right out to the event in Vault Radar. Likewise, our resource as well too. If I was to head back out here, right? If we were to go back out to resources, we can see we now have one high risk for this resource that we have. So same way of getting to same type of information, right? So we can open this up. And here we can see some details of the detection, right? Including an event ID. We actually have a unique secret ID as well too that's assigned to this specific secret, which can be helpful for identifying repeated secrets across resources. The location section shows where kind of the secret was found, and managed location tells us, right, whether it's been stored in Vault or not. But in this case, we actually want to go ahead and store this within Vault, right? So we are going to check the box for this event, and we're going to click on Store in Secrets Manager. And so since we already have our kind of remediate actions configured, Vault Radar shows us kind of the target context of this, and where we are going to store it within Vault, right? The store at path that we've already set up, right? Using that mappings CSV that I spoke about before. The only thing that it's going to prompt us for is the secret key, right? So the key for the value, which is the secret, right? And so I'm just going to name this Confluence credentials. And then as soon as I click confirm, it's going to kick off a process that's going to say storing secret in progress, right? And let's take a look at this. And there we go, storing secret in progress. And it should just take a second, right? And now if we scroll over, we have stored via Radar under the status there. It's still showing up as an event because I haven't resolved it yet. And we'll just leave this as is for the time being. But now, let's head over to Vault, right? I've got my Vault instance, and we can just take a look and make sure that it was vaulted correctly. So here is HTTP Vault. If you're familiar with Vault, this will look very familiar. And I just need to step down a couple of namespaces here. So I'm in the admin namespace, go to my own personal namespace, and then within here, I have a namespace called Vault Radar Copy Secrets dash namespace. And I've got a KV engine called Radar. And within there, we can see I have this backend path that's mapped to my repo, right? It's the same repo name as well too. And we can step in here and take a look at the secret that we have. And there we have Confluence credentials and the same secret, right? ATT3X. And we can see that this version was created at 10:20 a.m., right? Again, just a minute ago when I synced the secret, right? Pretty nifty, if you ask me. Perfect. So now the secret has been securely stored in Vault. We need to take that kind of next important step, which is ensuring that it does not remain exposed in our Git history. And to do this, we're going to be canceling the existing pull request and deleting the associated branch to prevent the secret from being merged into the main branch or recorded in the repository history, right? So let's head back out. Where are we here? Right. And I'm going to close this pull request. And then we are going to delete the branch, right? And so with that kind of unsecured branch removed, right, we could now create a new secure branch that would reference the secret directly from Vault instead of hard coding it in the code base. And we can go ahead and do that. It's a little outside, the Radar specific stuff, but I think in terms of how a process for how this would work in the real world shows, I think it's important to include as well too, right? So we'll go ahead and we're just going to create a new file real quick. Again, we can call this confluence.tf, and we're going to do this the correct way this time. And in this case, we're going to be using a data source to basically call out the location in Vault directly, right? So we're not hard coding, but we are having direct integration straight to Vault, so we don't need our users um, handling secrets at all. And then we are going to commit the changes. We're going to create a new branch, and we'll call this, we should call it something different. Let's say secured Confluence credentials. We're going to sign off and propose changes. Then, okay. And secured Confluence credentials against main. We'll create the pull request. Beautiful. And again, if I was coming in here to review this, maybe I take a look at what's going on. Hey, great. My, junior developer is not putting any credentials in plain text into our repo. Perfect. And then, it's good with me. I'm going to merge the pull request and confirm the merge. Right. And so by completing, this process, we've kind of successfully avoided introducing an unsecure secret into our Git history, really thanks to Vault Radar's detection and alerting capabilities. And so by canceling that original pull request and really replacing it with a secure, Vault integrated configuration, the application's now going to, pull the Confluence token from Vault at runtime, really eliminating that need to store sensitive data in the repo, which is going to strengthen our security posture of the project and really ensure that we follow best practices for secrets management. So that is about it. To summarize, I think we've seen how Vault Radar can help us detect and manage secrets across various platforms. We also demonstrated how to securely copy a secret from a GitHub repository into a Vault cluster using the key value secrets engine. And again, this process not only secures our secrets, but allows us to start using Vault immediately without handling the secrets directly. Really, overall, this is a powerful tool for any organization looking to improve their security posture. If you have any questions, please feel free to reach out to me directly or your account team, and we would be glad to talk to you about it in more detail. Thanks so much.